Hello guys, welcome to my YouTube channel Net Physics by Tanya. In today's lecture of nuclear physics, we will discuss some basic nuclear properties which includes charge, nuclear mass, nuclear size and nuclear density. So firstly, we will discuss about charge. In atomic notation, we have a particular way of writing an atom. So I have written here this ZXA, where this capital A represents the mass number, that is the number of protons plus number of neutrons. This capital X represents the symbol of element like chlorine, bromine, iodine, etc. And this capital Z represents the number of protons. So in the composition of nucleus, we have number of protons, number of neutrons as well as number of electrons. So here A minus Z is equals to capital N, which is number of neutrons lying in the nucleus. And we know that neutrons don't have any charge as they are neutral particles. So here in this figure we can define that an atom contains a nucleus, and in a nucleus there are neutrons as well as protons, and electrons surrounding the nucleus revolve in the outer region, that are electrons. Now we will study about our next property of nuclei, that is nuclear mass. We know that mass of any atom is equals to mass of nucleus plus mass of its electron. And here we can note that electrons are very lightly charged particle as compared to protons and neutrons. So we can say that 99% of mass of atom is contained in the nucleus, because as I already said that electrons are very lightly charged particle, so we neglect the mass of electrons here and we consider that 99% of the mass of atom is contained within the nucleus. So mass of nucleus is given by this formula: Z times of Mp plus A minus Z into Mn. Here this Mp represents the mass of proton, Mn represents the mass of neutron. So Z times of Mp represents the total mass of proton. Similarly, this A minus Z times of Mn represents the total mass of neutron. So here's the whole equation, that mass of nucleus is equals to Z times of Mp plus A minus Z times of Mn. So if we have to talk about the mass of atom, so it will be mass of nucleus plus mass of electron. And in the previous slide I have told that the mass of nucleus is given by this equation, Z times of Mp plus A minus Z into Mn. So mass of electron is given by Z times of Me. Why I have written this Z times of Me? Because if we have to talk about one electron, then we will write this Me only. But if there are Z number of electrons around the nucleus, then the total will be Z times of Me. So mathematically, we consider the nuclear mass in AMU. AMU is atomic mass unit. And in 1 AMU, the value is equals to 1/12 of mass of carbon atom. So here's the question arises in our mind, that why I have taken this carbon only instead of any other element like barium, chlorine, iodine, etc. There's a reason behind this, why we have taken only carbon as a standard form. Because when we observed the experimentally values and the theoretical values of carbon atom, that were lying so closely to each other that we consider carbon as a standard element. So I have written this, that experimental values are approximately equal to theoretical mass values. So we know that, so that's why we have taken this carbon as a standard element. And we know that Avogadro's number is given by 6.023 into 10 raised to power 23. Okay, so that's equal to n. So you can correct here that 6.023 into 10 raised to power 23. And if we have to talk about a gram of mass, so a gram of mass will be equal to capital N, that's Avogadro's number. So n atom has mass 12 gram in carbon. If we are talking about carbon, so one atom will have 12 by n. And in the above equation, I said that in 1 AMU is equals to 1 by 12th of the mass of carbon. So if we want in 1 AMU, then I just divided that factor of 12 by n by this 1 by 12 because we want in 1 AMU. So overall, after getting cancelling, it became 1 by n. So after cancelling the terms, we got 1 AMU is equals to 1 by n, and we know that n is what? Avogadro's number. So I put the value of n 6.023 into 10 raised to power 23, and after solving this equation, we got 1.66 into 10 raised to power minus 27 kg, which is equivalent to the mass of proton and mass of neutron as well as the mass of a nucleon. Now, if we have to talk about energy equivalent to AMU, means atomic mass unit. So in the previous slides, I told you that 1 AMU is equals to 1.66 into 10 raised to power minus 27 of kg. And if we have to convert this 1 AMU into energy, so we will use here Einstein mass energy relationship. We know that E is equals to mc square, where c is the speed of light, and we know the value that c is equals to 3 into 10 raised to power 8 meter per second. So after putting the values of m and c in the Einstein mass energy relationship here, we got that this equation as 1 electron volt is equals to 1.6 into 10 raised to power minus 19 of joule. So after calculating, we got energy in equivalent is approximately equal to 931 mega electron volt. So finally we got that 1 AMU is equals to 931 mega electron volt. So we got this thing in terms of energy in mega electron volt, and in mega that is equals to 10 raised to power 6 electron volt, means that is equals to a rest mass energy for a proton or neutron. So after getting this, we will say in future that is 931 mega electron volt is a rest mass energy for a proton or neutron. Now we will discuss about the next property of our nucleus, that is nuclear size. We know that in a periodic table there are some lighter nucleus and also some heavier nucleus. So these vary according to the mass number. As we move in the periodic table, we got that atomic mass increases with atomic number. So if the size is increasing, then volume is also increasing, and generally we consider nucleus as spherical shape. So for spherical shape, the volume is given by 4 by 3 pi r cube. So the relation comes out to be r is equals to r naught a raised to power 1 by 3. So how this relation occurs, as volume is given by 4 by 3 pi r cube. You can correct here. So as volume is increases with the atomic number, then volume is directly proportional to the atomic number A. So here you can correct this r cube. So 4 by 3 pi is a constant. So from this equation r cube will be directly proportional to A. So if r cube is directly proportional to A, then r will be directly proportional to A raised to power 1 by 3. So as I discussed that if r is directly proportional to A raised to power 1 by 3, then removing the proportionality sign, we used r naught as a constant of proportionality. So the equation became r equals to r naught A raised to power 1 by 3, where this r naught is a constant of proportionality and the value of r naught is given by 1.2 fm, where f is Fermi or femtometer, and 1 fm is equals to 10 raised to power minus 15 meter. Also, you can remember that is r naught factor is also known as nuclear radius parameter. Now, in this lecture, we will discuss about the next property of our nucleus, that is nuclear density. As we all know that density is equals to mass per unit volume. Therefore, for calculating nuclear density, the formula will become mass of nucleus upon volume of nucleus. So here we consider mass of nucleus as A. Therefore, nuclear density will become A upon 4 by 3 pi r cube, because we consider nucleus to be a spherical shape. So we have used the formula of volume of spherical shape, that 4 by 3 pi r cube. And also I have discussed in the last slide that the capital R is equals to R naught A raised to power 1 by 3. So using the value of R here in the above equation, we got A upon 4 by 3 pi R naught cube into A. So after cancelling the A terms on both sides, we are only left with this. And we know from the previous slide that R naught is equals to 1.2 fm. And also we know that 1 fm is equals to 10 raised to power minus 15 meter. So after putting all the values which we were aware about, we got this 2.97 into 10 raised to power 17 kilogram per meter cube, which is equivalent to 10 raised to power 17 kilogram per meter cube. So we can say that our nuclear density is equivalent to 10 raised to power 17 kilogram per meter cube. Like, share and subscribe my channel. Thanks for watching. Stay tuned for some more videos by Tanya.